So let us discuss this test. First question, which is the correct order of stated property? First is atomic radius. It's wrong because strontium is biggest and beryllium is smallest. Second, first ionization energy. Left to right, ionization energy increases, but ionization energy of nitrogen is more than oxygen because of stable configuration. Electronegativity maximum for fluorine. So this one is wrong. And electronegativity down the group decreases. So oxygen, selenium, tellurium. So correct answer is D. Next, which of the following are incorrect? Each atom has at least one orbital symmetrical about nucleus. Yes, it is s orbital. Each orbit has at least one orbital symmetrical about the nucleus with L0. That is again same. Number of electrons in neon having their angular momentum equal to 0 are 4. This one is also correct because 1s2, 2s2, 2p6. So these 4 electrons have angular momentum 0. Number of waves made by electron in an orbit will be equal to n plus 1. This is wrong because it is equal to n. So incorrect is D. Which quantum numbers are not consistent with the theory? And it is C because m can't have value more than L. Which statement is true? Elements in and beyond third period have only 3s and 3p orbitals available for bonding. That is wrong because they also have 3d orbitals. In large number of compounds, elements of third period are there are less than 8 valence electrons around the central atom. Less than 8 valence electrons are mostly in second period. C is PF3 and SF6 central atom have expanded octet. Expanded octet is not in PF3, it is according to octet rule. Elements which come just after lanthanide series have size less than expected. This is correct because of lanthanide contraction, so it is D. Which compound do not have hydrogen bonding? It is in D. HCl, no hydrogen bonding. In C, there is one water which is hydrogen bonded with sulfate. Water, again there is hydrogen bonding, KHF2, where HF2 anion, one fluorine is hydrogen bonded to H. Next, which is correctly matched? ClF3. ClF3, 2 lone pair and 3 bond pair, so it is T-shaped. XeO3, it is pyramidal. And XeF6 is linear, so correct one is third. And XeOF4, it is square planar pyramidal. So correct is C. Next, indicate the correct statement. Sigma bond has no free rotation. Wrong. There is free rotation. P orbital always have sideways overlapping. They also have axial overlapping. S orbital never form pi bond. This is correct. S orbital form only sigma bonds. Next is, if a mole is defined as 3 into 10 to the 4 instead of Avogadro's number, what will be atomic mass of argon? If it is Avogadro's number, then atomic mass is 40. This much atom have 40 gram weight. Then 3 into 10 raised to the power 24 will have how much mass? And that will be the molecular mass. It comes 200. Next is, how many moles of magnesium hydroxide can be precipitated? It is the reaction between magnesium chloride and KOH to give MgOH2 plus KCl. You have to find moles of magnesium chloride, moles of magnesium hydroxide prepared from 15 milliliter 0.2 molar and 25 milliliter 0.18 molar. So first we can find millimoles, M into V. M into V is 3 millimoles and M into V is 4.5 millimoles. Your limiting reagent will be KOH because 4.5 millimoles require 2.25 millimoles of magnesium chloride, which is 3 millimoles, that means magnesium chloride is taken in excess. If KOH is limiting reagent, then magnesium hydroxide formed will be half of this. And for moles, it is 1 by 1000. So answer is B. Next is ammonia formed in the following sequence of reaction. If to form 2 moles of ammonia, calcium should be taken. Here it is 2 moles of ammonia. Calcium cyanamide required is 1 mole. But if the yield is 50%, then 2 mole calcium cyanamide will be required. And here 100% yield. So for calcium cyanamide, 2 moles of calcium carbide will be used. And for 1 mole calcium carbide, 1 mole calcium is used. But 50% yield, then double calcium will be used. So if it is 2 mole of calcium carbide required, then 4 moles of calcium will be used. So answer is D. In every step, percentage yield should be taken. So 2 mole ammonia, 2 mole calcium cyanamide is used, and if yield is for 2 moles, 1 mole calcium cyanamide is used, and if yield is 50%, then it required will be 2 mole. First step. Then from the second equation, 1 mole calcium cyanamide require 1 mole calcium carbide, and yield is 100%. So for 2 mole calcium carbide will be required. And according to first, 1 calcium cyanamide require 1 calcium. Then 2 mole require 2 mole calcium. But if yield is 50%, then double will be required. Next is a compound have magnesium, carbon and oxygen by mass. Then first change them into moles. Like for magnesium 21.67 by 24, carbon 21.4 by 12, and oxygen 57 by 16. And these are the molar ratio. It is 1, it is 2, it is 2, and it is 4. So ratio will be 1:2, 2:4. Next is, among the following correct one is beryllium is smaller than magnesium. It is correct. Beryllium has a higher ionization energy than aluminium. This one is also correct. Charge by radius ratio of beryllium is greater than that of aluminium. It is almost same because they are diagonally related. And secondly, charge of aluminium is 3, increases by 1, so it is slightly more for aluminium, but otherwise it is nearly same. Both beryllium and aluminium mainly form covalent compound. This is also correct. So answer is D. Acidic, basic and amphoteric oxide respectively. First acidic oxide, second basic oxide, and third amphoteric oxide. So it is D. Next is, first ionization energy of magnesium is smaller as compared to that of element X and Y. First ionization energy is smaller than X and Y, but higher than that of Z. Then you have to identify these elements. Argon and chlorine, they have higher ionization energy than magnesium. Obviously, it is noble gas and it is halogen. But sodium, group 1, less than magnesium. So answer will be C. Correct order of conductivity of ion. In water, smaller the ion, more will be the conductivity. And cesium ion, aqueous cesium ion is smallest. Then rubidium, potassium and sodium. So correct is B. Here potassium is bigger. No, sorry. Aqueous potassium is smaller, but aqueous lithium has biggest size. So this one is wrong. Aqueous cesium ion is smallest because of least hydration, whereas aqueous lithium ion is biggest. Next is Which of the following option will illustrate law of reciprocal proportion? Reciprocal proportion, there must be three different elements. So in ammonia, nitrogen, hydrogen, water, hydrogen, oxygen, and dinitrogen pentoxide, nitrogen and oxygen. So basically there are three elements: nitrogen, oxygen, and hydrogen. And in every compound there should be only two elements. In ethanol there are three elements, so can't be applied this reciprocal proportion. Next is, in this experiment 0.25 moles of ammonia is formed when 0.5 mole nitrogen is reacted. Percentage yield. Nitrogen is 0.5 mole, hydrogen taken is 0.5 mole. So limiting reagent is hydrogen. If it is 3 mole, then 2 mole ammonia is required. It is 0.5. Then ammonia formed will be 1 by 3. That is 0.33. And actually 0.25 moles of ammonia actually formed. Theoretically is 0.33, actually is 0.25. So percentage yield will be 75%. Next is, what is the mole fraction of 12 molal methanol? 12 molal is 12 moles in 1000 gram water. That is 55.5 mole water. So mole fraction will be 12 by 12 plus 55.5. It is 0.178. Next is 2s orbital. The wave function is given by this equation. What is the value of r in terms of a naught at nodal point? At nodal point, psi will be 0, which is possible if 2 minus r by a naught is 0. So r by a naught will be 2. So r will be 2 a naught. Answer is B. Next is, electronegativity is not affected by stable electronic configuration. Yes, because it is the state, bonded state, property of bonded state. Electronegativity is the tendency of an atom to attract shared electron, not to gain electron. Yes, this is also correct. So both the statements are correct. It is D. Now integer, how many of the following will have fully filled orbitals with L2? L2 is d orbital. Iron have 3d6. Zinc, it is 3d10. So one is zinc. Then copper, 3d10, 4s1. So copper is also there. Silver, its atomic number is 47. Its configuration is 4d10, 5s1. So yes, it is same. Cadmium below zinc, 4d10, 5s2. So d10 configuration is there. Lanthanum 57, it is 5d1, 6s2. And mercury 80, it is 5d10, 6s2. So yes, it will be there. So there are 5 which have d10 configuration. Next is, an electron in ground state hydrogen atom absorb 10.2 electron volt energy. Find the shell to which electron will be promoted. Ground state energy is 13.6. If it absorbs 10.2 electron volt, then energy will be 3.4. minus 3.4, and energy of any shell is 13.6 by n square into z square, and E is minus 3.4. So here we can find n square. It is 4, n will be 2. Next is, how many of the following are correct for p orbital? This block contains metal, non-metal, metalloid. Yes, it is correct. And gaseous elements are present only in this block. That is also correct. Gases are only in p block, like oxygen and nitrogen, halogen. Oxidizing as well as reducing agent. Yes, because both metal and non-metals are there. And that is why oxides can be acidic, amphoteric as well as basic oxide. Variable oxidation state, this is wrong. No involvement of d orbital. As we go down the group, stability of higher valency decreases due to inert pair effect. That is correct. Lower valency increases, higher valency decreases. Electron affinity of third period is lowest in the group. This is wrong because third period element have highest electron affinity. In boron family, as we go down the group, atomic radius increases but irregularly. Yes, there is maximum irregularity in this group. Element of second period cannot expand their octet. Yes, it is correct due to absence of vacant d orbital. Metals of this block are highly reactive. No. S block metals are more reactive. So the correct one are 1, 2, 3, 4, 5, 6 and 7. How many of the following have single lone pair on the central atom? Ammonia, there is one single electron. SO2, one single electron. SF4, one single electron. And Cl5, one single electron. So there are 4 compounds. In CO2, there is no lone pair on central atom. In BF3, no lone pair. In methane, no lone pair. So answer is 4. Next, how many of them have zero dipole moment? SO2 is bent, so it will have net dipole moment. Methane is tetrahedral, so zero dipole moment. Chloroform, one atom is different in tetrahedra, so will not have zero dipole moment. And PF2Cl3, here 2 fluorine and 3 chlorine will cancel their dipole moment. So yes, it will have zero dipole moment. XeF4, 2 lone pair opposite, so net dipole moment will be 0. So yes, it is. Ammonia, irregular geometry, so answer will be 3.